This is the next question. We are given that let g of x comma y comma z be equal to 3x squared y positive z for x comma y comma z element of R. We are asked to find which of the following is the best approximation of the directional derivative of g at 1, 0, pi in the direction of the vector v bar is equal to I vector positive 2j vector positive 3k vector. Okay, so solution: g of x comma y comma z is given as 3x squared y positive z. So we are asked to find the best approximation of the directional derivative of g. Now the directional derivative for g is given by this formula: x comma y comma z is equal to delta g of x comma y comma z dot v vector over modulus of v vector. Okay, of course we can obtain it at this given point 1, 0, pi. Now foremost we will have to, I hope you are able to watch, we will have to get delta g of x comma y comma z. Now this is nothing but dou g of x, dou g of dou y, dou g of dou z, all partial derivative. Now g of x comma y comma z is given as 3x squared y positive z. So dou g of x, we have to differentiate with reference to x partially, so this is going to be 6xy, and dou g of y is going to be 3x squared, and dou g of dou z is going to be 1. So delta g of xyz is equal to 6xy, 3x squared and 1. Okay, so this is what we have got. I hope you are following it. Now at the point, gradient at the point, so therefore gradient, okay, at 1, 0, is it 1, 0, pi? So let me check that. Now this is actually 0, 0, pi, so this should be 0, 0, 0, pi. Okay, so this is going to be 6 of 0, 0 multiplied with 0, comma 3 of 0, comma, there's no point in substituting pi. Okay, it's just going to be 1 there. So this is going to give us 0, 0, 1. So delta g of x comma y comma z is equal to 0, 0, 1. So this is what we have got. Now we will have to take this value and substitute it over here, but before that we need to find v vector over modulus of v vector. So v vector is given. Okay, so v vector is I vector positive 2j vector positive 3k vector. So modulus of v vector is going to be root of 1 squared positive 2 squared positive 3 squared, which is root of 1 positive 4 positive 9, which is root of 14. Okay, so we've got that. So now therefore v vector over modulus of v vector is going to be I vector positive 2j vector positive 3k vector divided by root of 14. So this is what we got. So now what we have to do is we will have to find the direction derivative. So dv vector of g at 0 comma 0 comma pi is equal to 0 comma 0 comma 1 dot of I vector positive 2j vector positive 3k vector divided by root of 14. Now dot product, right? So these are all ijk components. So all the I vector j vector vanishes, we only have k vector. So we only take the coordinates. So since the dot product, this is also a k vector coefficient. So we all know that rule, right? I vector dot I vector is equal to 1. So this is going to give me 3 over root of 14. Okay, but we need to get the value. The question wants us to get a value. So this is approximately 0.8. So this will be the choice for this particular question. Okay, we can move on. Okay.